So today's lesson is going to be a little bit of 6-5 and a little bit of 6-6. We're actually not doing any of these full lessons because we don't do a lot of the properties that you're going to learn later on if you continue on in math about log. But we're going to learn a couple, actually really just one. And one of them is the main one is the change of base formula. So when I talk to you about what happens on the calculator, is if you have log base 5 and like let's say a 15 here, okay, you can't do that in the calculator. And really the question is asking you 5 to what power equals 15. That's the unknown right over here. So 5 to this power equals that. And there is no nice pretty x that's going to take 5 to that power to get you to 15, because we go 5 to the first would be 5. 5 to the second is going to be 25. So I know if it's going to fall somewhere in here, it's probably going to be somewhere around the 1.5 about, and I can approximate that because I'm looking at these numbers and seeing 15 maybe a little bit towards, maybe like this. That's my guess, somewhere around there. Might be a little low. But what we can do with this formula is I can actually now use a calculator because I can change this. It's called a change of base formula, which means I can change it to whatever freaking base I want to by just making it this, and I can make this a whatever I want. And so if I'm smart, I'm going to use this problem right here. I would make this become log 15 over log 5. And what that means is I no longer am using 5 as my base. I am using now a 10 because there's nothing written here. It is understood. So I can actually use the button in my calculator. So let's see if I have my calculator pulled up. I don't. So I got my calculator, and I can actually do with this calculator. I think you have to hit log after you hit the button. So I'm going to have to hit, let me see, what was it? 15, 5. So 15, then log. That's the log of 15. Divided by 5. And now I hit log. And so you can see right there what this did is it did log 15 divided by the log of 5. And I think that is right. That answer right there is just the log of 5. So I have to hit enter, which I did. There we go. That is now the answer. So it's 1.68. It's a little low. It's a little bit higher than I said. But fairly close. So again, when I did this, got to be careful. You have to 15, then log. And this answer right here that's appearing is the log of 15. Now when I hit divide, I go 5 and then log. Right now the calculator, this is the log of 5. It has not done the log 15 divided by 5, so that's why I have to hit enter one more time, and now it actually did the full thing. And that's where I get the 1.6. So that's called the change of base formula. You can use that anytime. That allows you to change it from a 5, whatever number you want to base 10. And the reason we use base 10 is because it is the one we can use in calculator. Technically, I could make it to a ln or a e base, so I can make this, and I'll show it to you on the calculator. You could actually do ln of 15 divided by ln of 5. That's, I changed the base and I changed it to a base e, which is perfectly fine. I just normally use log base 10. I don't know, just feels less scary. All right, so let's see if we get the same number when we do this. So 15 ln. All right, did we get the same number there? No, we're not going to get the same number there. Divided by 5 ln. We're not going to get the same numbers we did before, but when we hit that equal sign, boom, we got the same numbers we did. You can see it all right here. See? Same exact thing as we got last time. All right. So that is called the change of base formula. Very, very, very useful. So you can use that anytime. A little trick to get you answers. All right, another thing when we're trying to solve these guys, what we want to do is make them have a common base, because once we've talked about this already, once we make them have a common base, we can then go ahead and solve them. Well, the problem with this one is I can't make a half become a 4, and I can't make a 4 become a half using exponents. So sometimes when that happens, what I'm going to have to do is change both bases. So what you're going to say is, how can I change 1/2, and how can I change 4 so that there's some number to a power? And this is also that same number to a power, because I can't make this become that as something to a power. So what we're going to do, we're going to say, hey, I can make them both become 2's. So I can rewrite this. This is 2 to the first. Well, if I want to pull it up, I do the opposite of that negative thing, and I make it a negative, right? Normally we make a negative go to the bottom. Well, if I'm bringing it up, I can make the exponent become a negative. So 1/2 is the same thing as 2 to the negative 1. And 4 is really the same thing as 2 to the second. That's all they did right there. All they did is they replaced this 4 with 2 squared, replaced this half to here. Now, when you have power to a power, you multiply these. So you're going to see them multiplying. Negative 1 times x is a negative x, which is right there. Negative 1 times a positive 7 is a negative 7. That's what they got right there. And then 2 times 3x is 6x. Now, once you get the bases to the same, if I have 2 to the x and I say that equals 2 to the third, right? That means that x has to be 3. Once the bases are the same, that means the exponents have to equal each other. So as soon as we do this, we now have our bases being the same, 2 and 2. So what has to happen is I know that the x minus 7 has to equal the 6x. And then algebra comes in. I'm going to work backwards and get the x by itself. So I'm going to add x. That's how they got 7x on this side. Divide by 7, and that's how they got negative 1. All right, so here's what I want you to do. I want you to try this right here. You're going to practice that and pause the video in just a second. And then I'm going to, so you can pause for right now. Try to work these two on your own, and then I'm going to do them and see if you got what I got. So here we go. You should have unpaused now. You should have tried this and see what you got. Both of these need to change base because I can't make a 25 become a 125, and I can't make a 125 become a 25, but I can make a 25 become 5 squared, and I can make a 125 become 5 cubed. And so I can rewrite this as 5 squared. That replaces a 25 to the 3x. And that's supposed to equal 5 cubed, which replaces this to the x plus 2. And we know we do power to power, we multiply those guys. So I get 5 to the 6x equals 5 to the 3x plus 6. Bases are the same, so that means these two things have to be equal. So 6x equals 3x minus 6 plus 6, sorry. Minus 3x minus 3x. 3x equals 6 divided by 3 x equals 2. Boom. This next one's a little tricky. You have to remember powers. So really, when I move this, this is 1, 2, 3, 4. So I move that over 4 decimal places, which means I can rewrite that as a 10 to the negative 4th. Because what a negative 10 to any power is just going to move the decimal. So 10 to the negative 4 is going to be the same thing as this. And that equals 10 to the 6x. And then once these are equal, that means negative 4 equals 6x. Divide by 6, divide by 6. Negative 2/3 equals x. Just reduced it. All right, finally, the last type of ones we're going to talk about is when you have the ln right here. And the ln, really, this ln and this ln, it's like I can e this side and e this side, and all it does is cancel out the ln's. And that's what they do right here. And when they do that, you'll get left with this equaling that. And then just is what we talked about at the beginning. How many different types of x's do I have? I have 2 types of x. I cannot solve this by isolation like we did in the one before. We're going to have to move that over there, set it equal to 0. So they minus 6x on both sides. That's how they got this. They set it equal to 0. They're going to factor this. This says different signs, which is why they end up with this. The bigger sign is going to be negative. That's why the negative is here. Two numbers that multiply to 16 but subtract to 6, 8 and 2. That's how they got that. And then they said, what makes this bubble 0 is an 8. What makes this bubble 0 -2? We've talked about this in the past. And then they go ahead and say, you must check your work and plug it in. And when you check it, this side works. When you check it, this side does not work. And the reason is if you actually put this in the calculator, there is no negative values for it, right? So that's why there's these. This is an extraneous solution. We are coming very close to the end of this chapter that I'm going to put together and ask you to take a quiz on, because the next one is geometric sequence and series and stuff, and I'm going to do that as its own little activity and quiz. So be looking out for a quiz to be happening here very soon, with a review happening probably at the beginning of next week. So you'll do this. You'll probably do a examples on this on Monday and Tuesday. We'll probably, or maybe just Monday, and then we'll do like a live session on Tuesday, and then Wednesday, Thursday review, and probably Friday a quiz that you have the whole weekend to complete it on. Something like that. So that's just an upcoming view of this next week. And if you have any questions, please let me know. Right here, what you can do is say, hey, I'm going to take and I'm going to put 5 to all this power. What that does is cancel this out, and all it does is make x squared minus 45 equal to 4x. We have to set it equal to 0 because there's 2 types of x's. X squared minus 4x minus 45 equals 0. This says different signs. This says the bigger one is negative. 2 numbers that multiply to 45. Let's subtract to 4, 9 and 5. The bigger one's here, 9, 5, 9, and then -5. And you have to check them. And when you check them, you put them in your calculator. 9 is going to work, but again, -5 is going to be extraneous, because when you put that into the calculator, it's going to give you a negative value, and it's not going to like that. Same thing over here. We can put this to the e power. All that does is cancel this out and this out. -4x minus 1 equals 4x squared. Remember, it's not always about moving it to whatever side it has the least amount. I want to keep this thing positive, so I'd actually move all this crap over to here, because I want to keep that 4 positive. So this would turn into 0 equals 4x squared plus 4x plus 1. I'm going to check a special case, because this has a square root and this has a square root. The square root is 2x. The square root is 1. When I multiply these together, I get 2x, and when I double it, I get that. So boom, this is a perfect square, and my answer would be 2x plus 1 squared, which means x would equal a -1/2. The reason I know that's because that's what would make this 0. What you would do is you do 2x plus 1 equals 0 minus the 1 minus the 1. 2x equals a -1 divided by 2 divided by 2. X equals a -1/2. All right. I hope that video makes sense. I hope you understand the upcoming weeks of what we're going to do, and just take notes from this. Make sure you post those notes for me so I can see that you took them, and then have a great weekend. So happy Friday, and I'll talk to you guys again later.